Okay, time for part 2 of algebra. So hopefully you've already seen the first video or you've been part of the Zoom class and you tried a few examples yourself. This is going to be a recap of what we did in the second Zoom session on algebra. What we're going to do is we're going to take similar ideas, but we're going to make them a little bit more challenging. So just a reminder from last time that what we're doing when we're doing algebra is we are working with an unknown quantity. So the example I always gave you was my age. I wasn't going to tell you what it was, so you had to represent it with a symbol. And usually we use the letter X when we don't know something. And your job whenever you're doing algebra is to find X. So, hey, look, I just found X. I'm already done. Yeah, I know. Okay, bad joke. Stop the booing. Okay, so yeah, bad joke. You have to find the value of X, not find where it is. So here, a lot of you looked at this and said, well, X has got to be 7 because 7 plus 3 equals 10. And you're right to think that. But what you need to start doing is showing it by writing down a procedure. So what we did last time was we realized that I got to get this letter by itself. That's my main goal in algebra. And right now it's not by itself. It's got a plus 3 next to it. What we did before was we said, well, the opposite of plus 3 is minus 3. So I'm going to take away 3 from the left. I can change this any way I want. But if I do that to the left-hand side, I must also do that to the right-hand side. So by taking away minus 3 from the left, I also have to take away minus 3 from the right. That leaves me with just X now on the left. And 10 minus 3 equals 7. So it's great if you figured this out in your head, but this is how you show it. You show yourself getting the X by itself by taking away 3 from each side. Another way that we did this last time was here I'm saying 8 times Y equals 72. A lot of you figured out right away that Y must be 9, but the way you show that is doing the opposite of a multiplication by Y. The opposite of multiplying by 8, sorry, I meant the opposite of multiplying by 8 is dividing by 8. So if I divide the left by 8, I've got to divide the right by 8. Whenever you do this, the 8's go away. I've got the same thing on top, same thing on the bottom. So I'm left with just Y, which is what I want, a letter by itself. 72 divided by 8 is 9. This is another example that we did very quickly. I don't like seeing fractions here, so I'm going to get rid of it. This is Z divided by 9. The opposite of dividing by 9 is multiplying by 9. So I'm going to times the left by 9, but that means I've got to times the right by 9. This gets rid of that bottom 9. It leaves me with just Z on the left. And that means Z is equal to 3 times 9, which is 27. So we've already done these. But now what I'm going to do is I'm going to give you some examples that are a little bit probably too tough to do in your head. So you're going to have to get in the habit of writing them down like this. But before we do that, I'm going to start off with something easy that you've already seen before. So why am I showing you apples? Well, I'm just saying that 3 apples, if I don't want to draw them out like this, I can just maybe write them like this. 3 apple sign means I've got 3 apples. If I want to add 2 more apples, I don't really want to draw them out like this, so I'm just going to write it like this. 3 apples plus 2 apples equals 5 apples. Here's another version of or way to do it. I've got 8 phones here. If I subtract 2 phones, I'm going to obviously have 6 phones. So obviously you know this. But what I'm doing is I'm using these symbols to show you something that you can do algebraically as well. So enough of the drawing symbols. It's taking too much time. What if I just showed you something like this? 7 apples minus 3 apples. Well, that's nice and easy. You know it's 4 apples. What if I do 38 phones plus 11 phones? Well, that's going to be 49 phones. What if I do 15 centimeters plus 8 centimeters? Obviously going to be 23 centimeters. You can treat centimeters just like they are symbols. Here, 4x plus 9x. You can pretend that the x is just like one of these little symbols, and we can simplify this. So 4x plus 9x is actually 13x. You need to know this because you are going to see things like this where you have to add up what we call like terms, just things that involve x's together. Or we could subtract them. 7x take away 6x is going to be 1x. And by the way, usually in algebra, we don't write the number 1. We would be more likely to just say x. You're not wrong if you say 1x. It's just that this also means 1x. And we'll probably use that a lot more. So here's an example. Right off the bat, before you start this, and this is one that you probably can't do in your head, I would write this down. We've got something that we can simplify. 5x plus 3x. It's like saying 5 apples plus 3 apples. What do we have now? We've got 8 apples, or 8 x's, I should say. Plus 2 equals 26. Can I add that 2 to the 8x and say 10x? The answer is no. These are different things. You are not allowed to mix numbers that are by themselves with letters. Okay, not allowed. But what I still want to do is I want to get that x by itself. That was always my goal. That is still my goal. So I'm going to get rid of this plus 2. The opposite of a plus 2 is a minus 2. And if I do that to the left, I have to do that to the right. 26 minus 2 is 24. And now I'm left with just 8x equals 24. And this looks like one of the ones that we did last week. All we have to do now is divide both sides by 8. Because whenever you divide by the same number, that's a good way to get rid of the number in front of the letter, the x. And we're left with just x equals 3. One other thing that we should do now that we have our answer is we should test it just to make sure that we got it correct. You should be able to take the value that you got for x and replace the x in what you started with. And if I do that, I replace the x with 3. I do 5 times 3 plus 3 times 3 plus 2. Well, 5 times 3 is 15. 3 times 3 is 9 plus 2. It does equal 26. If it didn't, it would have meant that I made a mistake. So here's a different example. And if this is going too fast, by the way, just pause the video and rewatch it again. But here's another one. X plus 4 all divided by 9 equals 4. My head might be in the way. I'm not able to move it. Sorry. But what you're going to do is you are going to multiply both sides by 9. I'm just like you. I don't want to see fractions when I'm doing algebra. So the opposite of this big division by 9 is a multiplication by 9. If I do that to the left, that'll take care of that bottom 9. But remember, everything I do to the left, I have to do to the right. So that takes care of that. That gives me just x plus 4 on the left equals 36 on the right. We're almost done. All I have to do now is I have to get rid of that plus 4. Well, I'm going to do a minus 4 to get rid of it on the left, which means I've got to do minus 4 on the right. That leaves me with just x, and 36 minus 4 is 32. One more time, I'm going to test my answer just to make sure that it's correct. Here is what we started with. If I replace the x with 32, 32 plus 4 is 36. Divide by 9, it does give me 4. So this is correct. Remember, if this doesn't work when you're checking, if you get two numbers that are different, that means we've made a mistake. So here is another example. And what I want you to notice here is I've got x's on the left and the right, and I've got regular numbers on the left and on the right. That's not going to work out so well. I want to have all the x terms on one side and all the regular number terms on the other side. So I'm going to have to do a couple of things to this one. What should we do first? How about we get rid of this -3 over here? Well, the opposite of a -3 is a +3. And if I do that to the left, I also have to do it to the right. So on the left now, I'm left with just 5x. On the right, I've got 3x plus 1, but now I've added 3, so it becomes 3x plus 4. We're still nowhere near done yet. How about we subtract 3x from this side, because I don't want to see any more letters on this side. Well, if I do that, I've got to subtract it from both sides. So 5x take away 3x is going to be 2x. 3x plus 4 take away 3x leaves me with just the 4. We're almost done now. The last step is I've got 2 times what number equals 4? Well, by now we should realize it's going to be 2. But just to show that, I'm going to divide both sides by 2. 4 divided by 2 gives me my x value of 2. And again, I should always check my answer. Here's what we started with. Let's replace the x by 2. 5 times 2 is 10 minus 3. That equals 7. On the right, I've got 3 times 2, which is 6 plus 1. That also equals 7. So we've got 7 on each side. We are good. Another example here. This one may look a little bit complicated, but let's do what we've been doing all along. The big thing, I agree, or as I've been saying before, I don't like seeing fractions in algebra together. So I'm going to get rid of this division by 2x. The opposite of dividing by 2x is a multiplication by 2x. But that means I've got to multiply the other side by 2x as well. Well, what I've done is I've just gotten rid of the 2x's on the left, meaning I've got just 5. On the other side, I've got 10 times 2x. That's going to be 20x. So 5 equals 20x. Whoops. My next step is I've got to get that x by itself, which means I've got to divide it by the number in front of it. So I'm going to divide it by 20, which means the other side has to be divided by 20. That will cancel out. 5 divided by 20 is 0.25. So 0.25 is your value of x. And yes, you are allowed to get decimals or fractions when you're doing algebra. So don't be intimidated by that. It's just a different number. We can still test our answer. If I do 5 divided by 2x equals 10, what we started with, and I replace the x with what we just found, 0.25. Well, 2 times 0.25 is going to be 0.5. If you do this, 5 divided by 0.5, you will get 10. So we did find the correct answer. And now that we've done that, we're ready for some word problems. I can tell you're all so excited. So here is a word problem. It may look a little bit confusing, but we're going to approach this with a algebraic strategy. Yeah. So the combined ages of 2 cousins is 42. One cousin is 8 years older than the other one. How old are they? Of course, I've not told you either of their age, but I have given you enough hints that you can figure them out. So here is your strategy if you encounter an algebra word problem like this. First thing we're going to do is we're going to try to figure out the age of the first cousin. I haven't told you, so like many things we do when we don't know, we're going to call it X. The other cousin is 8 years older than this first one. So if your age is X and your cousin is 8 years older, then your cousin's age must be X plus 8. And what I'm telling you now is that if I add the cousins' ages together, they must total 42. So what we can say is X plus 8 equals 42. We've just come up with an equation. And if we solve it, we are going to find out what the value of x is. So here is what our equation looks like. This again is the first cousin, this x plus 8 is the second cousin, and this is the total. So let's actually solve this now. I've got x plus x, that is actually 2x plus 8 equals 42. Next step, let's get rid of the plus 8 here. The opposite of a plus 8 is a minus 8. If I do it to the left, I've got to do it to the right. So now I'm left with just 2x on the left. 42 minus 8 is 34. Almost done. I've got to divide both sides now by 2 to get that x by itself. So 2x divided by 2 gives me just x, which is what I want. But I've got to divide this side by 2. 34 divided by 2 means x is 17. And as always, I should check. Let's replace the x with 17. 17 plus 17 plus 8 equals 42. So we are correct. And then we could write a little sentence and say that one cousin is 17 years old, the other one is 25 years old. Okay, so this is how you would solve a question like this. I mean, maybe before this, you would have just started guessing random ages and checking, adding 8 to the age that you just came up with and seeing if it totals 42 until you eventually got to the right answer. That'll work, but it's not a great strategy. Solving this algebraic thing, though, is a much better strategy. It will work. So with that in mind, I am going to give you, I already said this on Zoom, the most ridiculous question I have probably ever asked. But let's stay positive. Let's handle this. Don't panic. And I know my head is in the way of this one. It says, during an intramural basketball game earlier this year, the Photons scored less than twice the number of points scored by the Ninjas. Meanwhile, on another court, the Chemists played the Lamborghinis. The Chemists scored twice as many points as the Ninjas, while the Lamborghinis scored 12 fewer points than the Photons. Both courts had the same point total. Determine the score on each court. I ran out of breath there. If you're looking at this and you have a headache, I don't blame you. So do I. And I would not ask you this kind of thing on a test, but let's walk through this and see that we can actually figure this out. And by the way, is this a true story? No, I made up these numbers. I may or may not have rigged these numbers such that we win. That doesn't sound like me at all, does it? So here's the important part of this for now. What I'm saying is that there was a basketball game on one court between our class and the Ninjas. There was another game on the other court between the Chemists and the Lamborghinis. Whatever the score was on our court, if you add up our points plus the Ninjas, it's the same total if you add up the Chemists versus the Lamborghinis. So we don't know that number, but we just know that the total points scored on court 1 are the same as the total points scored on court 2. So with that in mind, I can say this. The number of points scored by the Ninjas plus the number of points that we scored is equal to the number of points the Chemists scored plus the number of points the Lamborghinis scored. So my other hint for you, if you're actually getting a question like this, is I'm going to say, let's assume that the Ninjas value, we don't know what it is. I've not given you any number, but the Ninjas scored X amount of points. Well, for us, it says the Photons scored 3 less than twice the number of points scored by the Ninjas. So 3 less than twice of that, I have to add that, but would be this part over here. So twice what the Ninjas got minus 3. That is how many points we scored. Let's look for the Chemists here. It says the Chemists played the Lamborghinis. The Chemists scored twice as many points as the Ninjas. So if the Ninjas have X, the Chemists must have 2X. Then finally, how many points do the Lamborghinis have? The Lamborghinis scored 12 fewer points than the Photons. So I'm going to take what we got, and I'm going to put it over here, minus 12, because they got 12 fewer points than we did. So this must all look pretty complicated. I get it. But it's just reading the situation and turning it into something algebraic. And just we're doing it many times in one question. Now that we've got this, we can put this together into an equation and we can do a little bit of simplifying. Remember how I said you can add all the X terms together? Well, on the left, I've got X plus 2X minus 3. I can simplify these ones. I can turn this into 3X minus 3. Over on the right, can I do any simplifying here? Yeah, I can. 2X plus 2X is going to be 4X. Minus 3 minus 12, return of negative numbers. Minus 3 minus 12 is minus 15. So I'm going to have 4x when I add these together, and minus 3 minus 12 gives me minus 15. So I haven't changed anything right now. This is the equation that we came up with, and this is just after I simplify it a little bit. Now we can try to figure out the value of x. So let's see. The first thing I'm going to do is I only want to have x's on one side. It could be the left, it could be the right, but I don't want to have them on either side like I see here. So let's get rid of the one on the left. I'm going to subtract 3x, which means I've got to subtract 3x from the other side as well. That means that on the left, I have only minus 3 remaining. 4x minus 3x is just going to be 1x, or x, minus 15. This is what it looks like after I subtract 3x from each side. Now, I got to get that x by itself, and it's got a minus 15 there. The opposite of a minus 15 is a plus 15. So if I add 15 to here, I've got to add 15 to there. And that means I'm left with just x equals 12. There we go. We have found the value of x. So now that we figured that out. If you wanted to, you could find out what everybody else got for points. So what I'm saying is if X is 12, the ninjas had 12 points. We had twice or 3 less than twice that. It's weird to say. But 2 times 12 minus 3 is 21. So we won the game 21 to 12. For the chemists, they had 2 times 12. So they had 24 points. And the Lamborghinis had 2 times 12 minus 3 minus 12. 2 times 12 is 24, minus 3 minus 12 equals 9. So there you go. We won the game 21-12. Meanwhile, over on the other court, the chemists defeated the Lamborghinis 24-9. In real life, the Lamborghinis, I think, were the only team that beat us, so they get punished by losing in my made-up math problem. So yes, this was pretty complicated. There was a lot going on here. Is it reasonable for you to take all this information and come up with this? That's a bit tricky right now. That's Sec 2, maybe even Sec 3 or 4 level. But this part, we're starting to see how this works. Hopefully we'll be able to solve this with a little bit of practice. And if you want, just for fun, here is a little quick trick that you can do that you'll be doing a little bit more of in Sec 2. And it says you can move a part of an equation directly to the other side, just to save you a little time, as long as you change its sign. It's what we're doing already, but it looks a little bit quicker. What do I mean by changing a sign? It means if something is positive, I change it to be negative. And if something is negative, I change it to be positive. So here is an example of an equation. And I'm going to solve this a little bit quickly. I want to get x's all on one side. They're on either side right now. That's not good. So everything with an x has to be on one side. Anything without an x has to be on the other side. So how about we move the 5x over to this side? I can do that. I can just slide it over here and move it to the left, but I have to make it negative. That's what I mean by changing its sign. And that's what I've done. Now, I want to have all the numbers on the other side. I had a minus 3 over here. It's got to go to the other side. But if I take it to the other side, the minus 3 becomes a plus 3. And then I can move it over to the other side. And now I've got what I want. I've got all the x's on the left, all the numbers on the right. Now let's simplify it. 8x minus 5x is 3x. Plus 3 plus 9 is 12. If I divide both sides by 3, I will get the x completely by itself, and it'll tell me that x is 4. And of course, we should check our answer. If I replace x with the number 4, 8 times 4 is 32 minus 3. That'll be 29. And on the right, 5 times 4 is 20 plus 9. I get 29 again, which is good. It means we've done it correctly. Here's one more example. First of all, don't like seeing divisions. So let's multiply both sides by 5. That'll immediately get rid of that bottom denominator. So the 5's on the left cancel. This means I've got now x plus 12 equals 5 times x, which is 5x. Same thing as before. I want to get all the x's over to one side. So I'm not going to animate it like I did before. I'm just going to say, let's get this x over to here. So if I move the x over to here, remember I've got to change its sign. It's going to be 5x minus x once it comes over here. So 5x minus x is 4x. That is what is equal to 12. If I divide both sides by 4, I get my answer of x equals 3. And I don't have a part of the PowerPoint checking it here, but if I have 3 plus 12 divided by 5, that'll give me 3. It will work when I check. So that is a couple of examples of different algebraic calculations that you can do, or examples that are a little bit more challenging than the ones we saw last week. But now that you've got that, you can handle number 21 to 30 in this algebra worksheet that I have sent you. If you want more of a challenge, you can try number 31 and 32. They're a little bit more difficult, and they use some techniques that you may not have seen yet. And if you want even more challenging ones as well, I'll put up a couple of optional ones on the website. See if you can find them. So that's, again, completely optional. You don't have to do the ones on the website, but this one, try up to number 30. Rewatch part of this video if you need a bit more of an explanation. Pause it and go to the part that you need. Good luck.